this equation, if we start with 2 grams of salicylic acid and 4 milliliters of acetic anhydride, we're going to find how much of each product we're going to have, and also we're going to have to find the limiting reactant in this equation. So first of all, we want to know how many moles of salicylic acid we're using in this equation. We start off with 2 grams of salicylic acid, and we look up here and we have our mole ratio of salicylic acid. So when we divide these, our grams cancel, we end up with moles. Once we calculate that, we end up with, we are going to use the mole conversion factor to find how much aspirin we're going to produce. We want to make sure that salicylic acid is in the denominator of the conversion factor so we can cancel them out. So when we have 1 mole of salicylic acid, we produce 1 mole of aspirin. This is a pretty easy equation because all the ratios are just 1 to 1. We cancel out salicylic acid and we end up having 0.0145 of moles of aspirin. Same kind of conversion factor to find the moles of acetic acid that we're going to produce. So again, we have the 1-to-1 ratio. We cancel out salicylic acid, and since they're all 1-to-1 ratios, we will also end up with 0.0145 moles of acetic acid. Given the volume of acetic anhydride we have and the density, now we have to find the mass. So if you recall, density equals mass over volume. Density is 1.08 grams per mole, and we're finding the mass over 4.00. Now we need to find the grams. We have 4.32 grams of acetic anhydride. And I'm going to abbreviate that as AA. So, and now we need to do the same thing that we did with the salicylic acid to find the moles that we have. So we're going to start with 4.32 grams, and as we can see up here, our molar mass is 102.090, and when we calculate that, we figured that we have 0.0423 mole. Conversion factor now to find out how many moles of aspirin we can produce from 0.0423 moles of acetic anhydride. So as you can see, for every 1 mole of acetic anhydride, we get 1 mole of aspirin, which is where this conversion factor comes from. Remember, we have acetic anhydride in the denominator of the conversion factor, so we can just cross them out and cancel them. So, and then we end up with 0.0423 moles of aspirin. See, these kinds of problems are really easy when you have just a 1-to-1 mole ratio, but they can get confusing when you have different ratios and you have to calculate lots of numbers and you can easily get them mixed up. Same thing to find how many moles of acetic acid we've produced, and we actually end up with the same answer again of 0.0423 moles of acetic acid. We can identify our limiting reactant. Limiting reactant is a reactant that will run out first, therefore limiting the amount of product that we produce. As you can see, salicylic acid will produce 0.0145 moles of aspirin and also 0.0145 moles of acetic acid. Acetic anhydride produces 0.0423 moles of aspirin and 0.0423 moles of acetic acid. So we can determine that salicylic acid is the limiting reactant because it produces less of each product. Now, these aren't always going to be the same. Every reactant and product had a 1-to-1 mole ratio, which would mean that they would produce the same amount. Now that we know how many moles of aspirin we produce, we can determine how many grams of aspirin we've produced. Now, we use the limiting reactant to determine how many moles of aspirin we produce, because remember, that's the reactant that's going to run out first. So if we try to calculate aspirin from the excess reactant, we wouldn't get the accurate amount of aspirin that we've produced, which would go off the numbers that we'll be calculating. So we're going to use a conversion factor also to find the amount of aspirin that we're going to produce. 80.157 grams per mole is the molar mass of aspirin. So we're going to multiply 0.0145 times the molar mass of aspirin. Once we calculate that, we end up with 2.61 grams of aspirin. Now remember, we want to use the right amount of significant figures here when we give our answer. So 180.157 grams has 6 significant figures, and 0.0145 moles of aspirin has 3 significant figures. You don't want to forget about this exact measurement here for the 1 mole of aspirin. That's an infinite number of significant figures, so you don't want to misinterpret that as 1 and then give your answer with 1 significant figure. So in the end, we will end up having 3 significant figures, which gives us our answer of 2.61 grams of aspirin.